Dear students, welcome. This is our third class on pair of straight lines. Let us start. The question is, find the equation of the bisectors. Equation of the bisectors of the angle find the equation of the bisectors of the angle between the straight lines. ax square plus twice hxy plus by square, this is equal to 0. Find the equation of the bisectors of the angle between the straight lines. This solution. You see, this is a homogeneous equation of second degree. Obviously, it represents a pair of straight lines passing through the origin. The two straight lines will be of the form y equal to m1x and y is equal to m2x. Since these two straight lines pass through the origin, let the straight lines represented by the equation, let the straight lines represented by the equation ax square plus twice hxy plus by square equal to 0, b y equal to m1x and y is equal to m2x. What will be the combined equation of 2 and 3? The combined equation of 2 and 3 is equation of 2 and 3 is y minus m1x into y minus m2x. This is equal to 0. This is nothing but y square minus m1 plus m2 into xy plus m1 m2 x square. This is equal to 0. Suppose this is number 4, equation number 4. You see, the equation 1 represents two straight lines passing through the origin. The straight lines are y is equal to m1x, y is equal to m2x. Suppose that. The combined equation of 2 and 3 is this. What does it mean? 1 represents two straight lines passing through the origin, and 4 also represents the straight lines passing through the origin. 4 also represents the same straight lines passing through the origin. 1 and 4 represent the straight line passing through the origin. Same straight lines, same pair of straight lines. Clearly, 1 and 4 represent the same pair of straight lines passing through the origin. Comparing 1 and 4 we get Comparing 1 and 4 we get 1 divided by the coefficient of y square is this minus m1 plus m2 divided by twice h. This is equal to m1 m2 divided by a. This means that m1 plus m2 is equal to minus twice h by b, and m1 m2 this is equal to A by B. M1 M2 equal to A by B. M1 M2 equal to A by B. We have got this. Now see, suppose these are two straight lines passing through the origin. What is the bisector of this angle? This is the bisector. This is the bisector. Also, another bisector is this. What is the bisector? If it is the bisector of these two lines, then the perpendicular distance from every point of this line on the two straight lines, this and this, will be same. Will be same. You see, if it is the bisector of the straight lines, this and this, then the perpendicular distance from each point on this straight line, on the two, from this straight line on these two straight lines will be the same. Will be the same. What are these two straight lines? It is y is equal to m1x. Suppose this is y equal to m2x. This is the straight line. Perpendicular distance. If you the perpendicular distance from any point, suppose x1, y1, from any point on this straight line, what will be this? y1 minus m1 x1 divided by root over 1 plus m1 square. Similarly, perpendicular distance from this point, suppose x1, y1, on this straight line y is equal to m2x, will be clearly y1 minus m2 x1 divided by root over 1 plus m2 square. What is the locus of this point? The locus of this point is the bisector. What is the locus of this point? Y minus m1x divided by root over 1 plus m1 square. This is equal to y minus m2x divided by root over 1 plus m2 square. This is the locus. Now the equation of the equations of the bisectors. On the straight line, on the straight lines 2 and 3 are y minus m1x divided by root over 1 plus m1 square. This is equal to y minus m2x divided by root over 1 plus m2 square and y minus m1x divided by root over 1 plus m1 square. This is equal to minus y minus m1x divided by root over m2x. This is m2x divided by root over 1 plus m2 square. The combined equation of the bisectors will be, therefore the combined equation of the bisectors, therefore the combined equation of the bisectors of the angle between the straight lines. The straight lines represented by 1, that is 2 and 3. The combined equation of 2 and 3 is 1 or 4. Combined equation of 2 and 3 is 1 or 4 of the bisectors of the angle between the straight lines represented by 1 is y minus m1x divided by root over 1 plus m1 square minus y minus m2x divided by root over 1 plus m2 square into y minus m1x divided by root over 1 plus m1 square. This will be plus y minus m2x divided by root over 1 plus m2 square. This is equal to 0. This is the equation of the bisector. Now we are to simplify this equation. Now we will simplify this equation. It is of the form a plus b into a minus b. This means it will be y minus m1x divided by root over 1 plus m1 square whole square minus y minus m2x divided by root over 1 plus m2 square whole square. This is equal to 0. It will be obviously this. This means y minus m1x whole square divided by 1 plus m1 square. This is equal to y minus m2x whole square divided by 1 plus m2 square. It will be like this. The equation of the bisectors will be this. Now simplify this. Y square minus twice m1 xy plus m1 square x square into 1 plus m2 square. This is equal to y square minus twice m2x y m2xy plus m2 square x square into 1 plus m1 square into 1 plus m1 square. This will be this. Now the coefficients of what is the number of terms? It will, from the left hand side you will get 6 terms. From the right hand side also you will get 6 terms. From these 6 terms you will get 1 plus m2 square minus 1 plus m1 square into y square minus twice m1 into 1 plus m2 square minus m2 into 1 plus m1 square into xy you will get this. Plus m1 square 1 plus m2 square minus m2 square into 1 plus m1 square into x square. This is equal to 0. You will get this one. You will get this one. Now 1 will be cancelled here. This means m2 square minus m1 square into y square. Here m1 square, m2 square, m1 square, m2 square will be cancelled. Minus 2 times of m1 minus m2 into xy. Oh no. It will not be cancelled. It will not be cancelled. Minus 2 times of m1 minus m2 m1 minus m2 and m1 m2 square minus m2 m1 square into xy. These terms will be cancelled here. These terms will be cancelled. Plus m1 square minus m2 square into x square. This is equal to 0. you'll get this one. Now, this means here you will get m1 plus m2 into m2 minus m1 y square minus 2 times of m1 minus m2 plus m1 minus m2 minus m1 m2 into m1 minus m2, and also 2 is here xy. No, it will be minus 2 times of this plus this plus m1 plus m2 into m1 minus m2 into x square. This is equal to 0. This is equal to 0. Now, since m1 is not equal to m2, divide it by m1 minus m2 minus, it will be definitely minus this into y square minus 2 times of, it will be 1 minus m1 m2 into xy plus m1 plus m2 into x square. This is equal to 0. Since m1 is not equal to m2, if m1 is equal to m2, then the two straight lines will coincide. If m1 equal to m2, the two straight lines will be coincide. This is equal to minus twice h by b y square minus 2 times of 1 minus, this is nothing but a by b xy plus minus twice h by b into x square. This is equal to 0. This is equal to 0. 2 will be cancelled. H by b y square minus b minus a divided by b into xy. It will be minus h by b x square. This is equal to 0. This term will be equal to 0. This means b cancelled. H into x square minus y square. If you take this term and this term into this side, right side, then you will get here a minus b into xy. A minus b into xy. This means x square minus y square divided by a minus b, this is equal to xy by h, which is the required equation of the bisectors. Which is the required equation? Is the required equation of the bisectors of the angles between the straight lines represented by ax square plus twice hxy plus by square. This is equal to 0. This is the required equation of the bisectors. X square minus y square divided by a minus b. This is equal to xy by h. This is the required equation of the bisectors of the angles between the straight lines represented by the general equation of second degree. Ax square plus twice hxy plus by square plus twice gx plus twice ax square plus twice hxy plus by square. This is equal to 0. This is the homogeneous equation of second degree. The equation of the bisectors is easy to remember. X square minus y square divided by a minus b. This is equal to xy by h square. xy by h. x square minus y square by a minus b, this is equal to xy by h. Easy to remember this. Now, relating to this problem, let us take a problem. Take a problem. The problem states as if the two pair of lines, straight lines, if the two pair of straight lines, x square minus twice pq minus y square equal to 0 and x square minus twice q xy minus y square, this is equal to 0. This has that. Each pair, this has that. Each pair of straight lines bisect the other pair. Then prove that PQ plus 1 equal to 0. Then prove that PQ plus 1, this is equal to 0. Then prove that PQ plus 1 equal to 0. We are given two pair of straight lines. The straight lines are like that. This is a straight line, pair of straight lines. Another two straight lines, this is a straight line. It bisects the angle between these two straight lines. It is also this. It also bisects the angle between the two straight lines. Not only that, these two straight lines also bisect the angle between the two straight lines. This angle is also equal to this angle. It is given that. Each pair bisects the angle, bisect the angle between the, bisect the other pair. Bisect the other pair. You may write like this also. Each pair of straight lines bisect the other pair. Yes, bisect the other pair. Bisect the angle, it definitely means the angle between the two straight lines. These two straight lines, this straight line bisect these two straight lines. What does it mean? It bisects the angle. This angle bisects. These two angles will be equal. This means that. Let us try to solve this problem. The given equations are x square minus twice pxy minus y square equal to 0, number 1, and x square minus twice qxy minus y square equal to 0, this is number 2. Equation number 1 and this is equation number 2. Now, as the previous article, we know that the equation of the bisectors of the straight lines, equation of the bisectors of the straight lines represented by ax square plus twice hxy plus by square is equal to 0 is x square minus y square divided by a minus b. This is equal to xy divided by h. This is the equation of the bisectors of this straight line. Therefore, the equation of the bisectors, therefore the equation of the bisectors of the straight lines represented by one will be represented by one will be represented by one will be. What is the equation of the bisectors of this? X square minus y square divided by a minus b. A is 1, b equal to minus 1. This is equal to xy divided by, it will be minus p, definitely minus p. This means x square minus y square, this is equal to minus 2 by p xy. This means x square plus 2 by p xy minus y square, this is equal to 0. Suppose this is number 4. Now see, the equation of the bisectors of 1 is given by number 3. Given by number 3. Equation of the bisectors of 1 is number 3. According to the question, equation of the bisectors of 1 is 2. What does it mean? 2 and 3 represent the same pair of straight lines. According to the question, equation of the bisectors of 1 is given by 2. What does it mean? This means that 2 and 3 represent the same pair of straight lines. This means that 2 and 3 represent the same pair of straight lines. Therefore, comparing 2 and 3 we get. Therefore, comparing 2 and 3 we get. Just compare 2 and 3. Here, x square, coefficient of x square is 1. Here is also 1. It is 2 by p. It is minus twice q. This is equal to minus 1, minus 1. This means that 2 by p divided by minus twice q equal to 1. This means minus 1 by pq equal to 1. This means pq equal to minus 1. This means pq plus 1 equal to 0. Proved. This proves therefore it is proved. Now let us take another example. Show that today's example number 3. Show that the area of the triangle formed by the area of the triangle formed by the straight lines ax square plus twice xy plus by square equal to 0. It represents two straight lines passing through the origin, and the line Lx plus My equal to 1 is, we have to find the area of the triangle formed by three lines. Two lines are these, represented by this. Y is equal to m1x suppose, and y is equal to m2x, passing through the origin. And the third line is this. What will be the area of this triangle? the area of the triangle will be equal to root over a square minus ab divided by bl square minus twice hlm plus am square. We have to show that the area of this triangle is this. Area of this triangle is this. Now, let us try to solve this problem. We know that this is a homogeneous equation of second degree. It represents two straight lines passing through the origin. Let the straight lines be y is equal to m1x and y is equal to m2x. Since the equation ax square plus twice hxy plus by square equal to 0, this is a homogeneous equation of second degree. Homogeneous equation of second degree. It will represent two straight lines passing through the origin. Through the origin. Let the two straight lines be. Let these two straight lines be y equal to m1x and y equal to m2x. And y is equal to m2x. Let the straight lines be y is equal to m1x and y is equal to m2x. The combined equation of 2 and 3 is y minus m1x into y minus m2x. This is equal to 0. This means y square minus m1 plus m2xy plus m1 m2x square. This is equal to 0. Suppose this is number 4. 1 and 4 represent the same pair of straight lines. 1 and 4 represent the same pair of straight lines. Comparing 1 and 4 we get 1 and 4 we get. Comparing 1 and 4 we get. Comparing 1 and 4 we get 1 divided by b. This is equal to minus m1 plus m2 divided by twice h. This is equal to m1 m2 by a. m1 m2 divided by a. This means m1 plus m2 minus twice h by b. m1 m2 this is equal to a by b. We have got this. Also the third line is lx plus my. This is equal to 1. Suppose this is number 5. Now what is our aim? We are going to find the area of the triangle. Suppose this is x-axis, this is y-axis. Suppose that two straight lines passing through the origin 2 and 3. Suppose that these two straight lines are like this. These are two straight lines. One is y is equal to m1x, another is y is equal to m2x. And the third line is suppose this one. lx plus my. This is equal to 1. We know that the point of intersection between 2 and 3 is 0, 0. If we can find the point of intersection between 2 and 5 and 3 and 5, then we will get all the points, all the suppose this is A, this is B, this is O. All the coordinates of the points 0, O, A and B. Definitely we can find the area of this triangle. We have to find the points of intersection between this points of intersection between 2 and 3, 2 and 5 and 3 and 5. We have to find the point of intersection. Obviously the point of intersection between 2 and 3 is 0, 0, since it passes through the origin. Now we have to find the coordinates of A and B also. Now obviously the point of intersection between 2 and 3 is O, 0, 0. Obviously, let AX1, Y1 and BX2, Y2 be respectively the points of intersection points of intersection between 2 and 5 and 3 and 5. 3 and 5. Since AX1, Y1, X1, Y1 is a point on 2 and 5, therefore we get Y1 equal to M1 X1 number 6 and LX1 plus MY1, this is equal to 1. Suppose this is number 7. From 7 you will get LX1 plus M. For Y1 you may write M1 X1, this is equal to 1 by 6. Using 6 you will get this. This means L plus MM1 into X1 equal to 1. This means X1 equal to 1 divided by L plus MM1. L plus MM1. L plus MM1. Now 6 implies. From 6 you will get Y1 equal to M1 divided by L plus MM1. Therefore, AX1, Y1. This point will be definitely L plus MM1, M1 divided by L plus MM1. Similarly, X2, Y2, it will be replace M1 by M2 here. 1 by L plus MM2, M2 divided by L plus MM2. X2 equal to this, Y2 equal to this. You will get this one. Now, we have got the points of intersection. X1, Y1, here it is X2, Y2. We have got all the 3 points, coordinates of 3 points O, A and B. Therefore, the area of the triangle OAB is, what is the area of the triangle OAB is half into 0, 0, 1, x1, y1, 1, x2, y2, 1. Or you can, you may write in this way also, x1, y1, x2, y2, 0, 0. This into this minus this into this. This into this minus this into this. This into this minus this into this. This is equal to, what is the area? You will get x1, y2 minus x2, y1. This is the area of the triangle. Now put the values of x1, y, x1. What is x1? 1 divided by L plus m1. What is y2? m2 divided by L plus mm2 minus, what is x2? x2 equal to this, 1 by L plus mm2 m1 divided by y1 L plus mm1. You will get this one. Get this one. You may get it here also if you want. Now, this is the area of the triangle. This is equal to half. You will get m2 minus m1, m2 minus m1 divided by L plus mm1 into L plus mm2. You will get this one. This is equal to half into, for this you may write m1 plus m2 whole square minus 4m1 m2 divided by L square plus Lm into m1 plus m2 plus m square m1 m2. You may write like this. This is equal to half root over minus twice h by b whole square minus 4 a by b L square plus Lm minus twice h by b plus m square into a by b. You may write like this. You may write like this. This is equal to 1 by 2. From this 2 will be, 2 can be taken outside this. Here you may write h square minus ab. H square minus ab. Here also 1 by b, bn square minus twice h lm plus am square. bb cancel, 2 cancel. This is equal to root over h square minus ab divided by bn square minus twice h lm plus am square. This is the area of the triangle formed by the straight lines represented by ax square plus twice hxy plus by square equal to 0, and the third line is lx plus my plus lx plus my. This is equal to 1. This is the required area of the triangle OAB. Wait, let us take another problem. Let us take another problem. This is today's question number 4. Today's question number 4. If the equation ax square plus twice hxy plus by square plus twice gx plus twice fy plus c equal to 0 represents a pair of straight lines represents a pair of straight lines then prove that the square of the distance is between the point of intersection square of the distance between the point of intersection of the straight lines square of the distance between the point of intersection of the straight lines from the origin is c into a plus b minus f square minus g square divided by ab minus a square. This is the equation. This equation, sometimes this equation represents a pair of straight lines. If abc plus twice f gh minus a f square minus bg square minus c square equal to 0. This represents a pair of straight lines. Then the two straight lines will meet at a point, which is the point of intersection between the two straight lines. If we find the distance between this point of intersection and the origin 0, 0, and if we square it, then that value will be equal to c into a plus b minus f square minus a square divided by ab minus a square. Let us try to solve this problem. Let the straight lines represented by, because it is given ax square plus twice hxy plus by square plus twice gx plus twice fy plus c equal to 0, b, it may not pass through the origin. L1x plus m1y plus m1 equal to 0 and L2x plus m2y plus m2, this is equal to 0. This is equal to 0. The combined equation of 2 and 3 is equation of 2 and 3 is, what is the combined equation of 2 and 3? M1x plus m1y plus m1 into L2x plus m2y plus m2, this is equal to 0. This is the combined equation of 2 and 3. Combined equation of 2 and 3 is this. This means, how many terms are there? 9 terms. 3 terms multiplied by 3 terms, 9 terms. You will get L1, L2 into x square plus L1, M2 plus L2, M1 into xy plus m1 m2 into y square plus L1 M2 plus L2 M1 into X plus M1 M2 plus M2 M1 into Y plus M1 M2. This is equal to 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. All the terms have been written here. Obviously, 1 and 4 represent the 1 and 4 represent the same pair of straight lines. Pair of straight lines. 1 and 4 represent the same pair of straight lines. Comparing 1 and 4, we get comparing the coefficients of 1 and 4, we get. If you compare the coefficients of 1 and 4, then you will get comparing the coefficients of 1 and 4. We get L1 L2 equal to A, M1 M2 equal to B, M1 M2 this is equal to C, L1 M2 plus L2 M1 this is equal to twice H, L1 M2 plus L2 M1 this is equal to twice Z, M1 M2 plus M2 M1 this is equal to twice F. We have got this. What is our aim? First, we have to find the point of intersection between the straight lines 2 and 3. The point of intersection between the straight lines 2 and 3 is it was L1x plus M1y plus M1 equal to 0, L2x plus M2y plus M2 equal to 0, 2 and 3. X divided by this into this minus this into this, M1 M2 equal to y divided by this into this minus this into this, L2 M1 minus L1 M2 this is equal to 1 by L1 M2 minus L2 M1. This means X equal to M1 M2 minus M2 M1 by L1 M2 minus L2 M1, y equal to L2 M1 minus L1 M2 divided by L1 M2 minus L2 M1. Therefore, the point of intersection between the straight lines represented by 1. Therefore, the point of intersection between the straight lines represented by 1. Intersection between the straight lines represented by 1. That is 2 and 3 is M1 M2 minus M2 M1 divided by L1 M2 minus L2 M1, L2 M1 minus L1 M2 divided by L1 M2 minus L2 M1. You will get this. This is the point of intersection between the two straight lines. Now, square of the distance between this point and 0, 0 and the origin 0, 0. Therefore, the point of intersection. Therefore, the distance between this point and 0, 0 is distance. Therefore, the square of the distance between the point. What is this? M1 M2 minus M2 M1 by L1 M2 minus L2 M1 L2 M1 minus L1 M2 divided by L1 M2 minus L2 M1 and 0, 0. Oh, 0, 0. And the 0, 0, you might write 0, 0. The origin is 0, 0 and 0, 0 is equal to M1 M2 minus M2 M1 by L1 M2 minus L2 M1 minus 0 whole square plus L2 M1 minus L1 M2 divided by L1 M2 minus L2 M1 minus 0 whole square. This is the required square of the distance. Now we have to simplify this, and we have to find the expression in terms of ABC, FG, H. In terms of ABC, FG, H. This is equal to, obviously, M1 whole square, M1 M2, M2 M1 whole square plus L2 M1 minus L1 M2 whole square. This is equal to, I am writing the opposite. I am writing. This is equal to, it is of the form A minus B whole square. This is equal to A plus B whole square minus 4AB minus 4AB M1 M2 N1 N2 plus L2 M1 plus L1 M2 whole square minus 4 L1 L2 M1 M2 divided by L1 M2 plus L2 M1 whole square minus 4 L1 L2 M1 M2 M1 M2. We will get this one. This is equal to, what is this? M1 M2 twice F whole square minus 4BC plus L2 N1 twice Z whole square minus 4AC. It is twice H whole square minus 4AB. 4AB whole square minus 4AB. This is equal to, you will get 4 F square minus BC plus Z square minus AC 4 H square minus AB. This is equal to F square plus Z square minus C into A plus B divided by H square minus AB. This is equal to C times of A plus B minus F square minus Z square divided by AB minus H square. This is the required square of the distances between the C into A plus B minus F square minus Z square divided by AB minus A square. This is the square of the distance between the point of intersection between the straight lines represented by the equation ax square plus twice sxy plus by square plus twice gx plus twice fy plus c equal to 0 and the origin and the point of intersection. The distance and square it. The result is c into a plus b minus f square minus a square divided by b minus a square. Dear students, it is 12:25 night. Therefore, I want to stop here. I shall take your class tomorrow also. Thanks for attending the class. Thank you very much. Thank you.